Please respond in the chat box because I understand that I was disconnected. So I hope you understand. No. Okay, I'll explain the fragmentation and reassembly one more time. Okay, fine. I will explain that one more time. Please give me a time to share my presentation. Okay. So in the field, okay, in the header, all of you please listen. Okay. So in the header, we have three fields: identification, flag, and fragmentation offset. Okay. So flags means there are two flags available. One is the D, the other one is M. Okay, D, one, M. All right. So there are flags. D flag. The first one is the D flag. All right. So if D equal to 1 means, okay, so there is a presence of fragmentation. Fragmentation is done. Okay. Fragmentation is yes. If B equal to 1 means fragmentation is yes. If B equal to 0 means no fragmentation. Okay, fragmentation is not done. All right. So this is the first flag that is checked by every router. Okay, any IP version 4 router will check this D flag to understand the presence of a fragmentation or not. Okay. Then M flag. There is one more flag called M flag. If M flag equal to 0 means that is the last fragment. Okay, that is the last fragment. All right. If M equal to 1 means that's intermediate. That may be a start fragment or that may be an intermediate fragment. All right. So when M equal to 0, it means that nobody else, no other fragment of that particular segment is coming. Okay, so I hope you understand about the flags. All right, there are two flags, D and M flag. Now there is one more field called identification. All right, so why do we need identification? That's a unique number that identifies a set of fragments. Okay, a set of fragments of a particular packet. Okay. It identifies the set of fragments of a particular packet. So if one entire packet is divided into 3 segments, 3 fragments, all the 3 fragments will have the same number. Okay, all the 3 fragments will have the same identification number. Okay, so I'll show you that. Okay, with an example. Here you see in this example. So this particular 4000 bytes datagram cannot be communicated in the link. So it is divided into 3 fragments. Okay, we have divided into 3 fragments. So you see the first fragment has 1, M flag is 1. The second fragment has M flag is 1. And the last fragment has M flag is 0. It means that this is the last fragment. Now you see the identification X, X, X. It means that all the 3 identification, all the 3 belongs to a single packet. Okay, that's the 4000 packet. Now coming to the offset. What is the offset? Offset is nothing but the starting byte of the fragment divided by 8. I'll give you the formula here. Offset is nothing but starting byte number divided by 8. Okay. And why do we need the offset? Okay, so why do we need an offset field? Is in order to arrange the fragment in order. Okay. So what will be the offset for the first segment? Always, okay. Always the offset for the first segment will be 0. Okay, always the offset for the first segment will be 0. So what about the, I'll show you this example here. All of you see this example? Okay, instead of this, this will be a little bit clear. See here, 4000 bytes. I want everybody to see this example. You have 4000 bytes. So the 4000 bytes is divided into 1400 bytes. Okay. Now the first 1400, it start with 0 and end with 1399. Okay. So the starting bit is, it starts with the number 0. So what is the offset value? 0 divided by 8, that is the 0. So put that as the first fragment. Okay, that will come as the first fragment. What about the second fragment, 1400 to 2799, the next 1400. Okay, So 2799. So what will be the offset? The starting number of that particular fragment divided by 8. That is 175. Okay. Similarly, the last fragment. Okay. The remaining numbers 28002 3999. Okay. So what will be the offset? 2800 divided by 8. Okay. So that is offset. Now I want to arrange it, okay, rearrange it. Again, I want to make it in order. How will I make it in order? Wherever m equal to 0, put it at the last, okay. Wherever offset is equal to 0, put it at the first. Then intermediate levels, you arrange the offset in ascending order. Okay, you arrange the offset in ascending order. The fragments will come in order. Okay, so I hope now you understand this. If you understand, kindly respond in the chat box. Okay, so that was good. All right. So shall we go to the next topic, options? Okay. So now we will explore the options available in your IP version 4 as well as version 6. Okay. So what are the different options available? For example, you have options called source root. Okay. So record root. All right. So what is that record root is? It's like your trace root. Okay. So you can just record the journey of the packet from source to destination. That is what you called as the source root. So there are two type of source roots. One is the loose source root and the strict source root. So what is that loose source root? Loose source root means it is the packet is given its own options. Okay, that the packet is given full freedom to take its own path. Right, that is what is you called as the loose source root. Then strict source root means it means that the packet should strictly take the path specified in the option field. Okay, in the option field, you will specify the IP address of the router that the packet should take. Okay, in that case, it is called as the strict source root. So otherwise, it is called as the loose source root. Okay, so then timestamp is one more option. And security is an option specially available in IP version 6. It is not available in version 4. Okay, it is available in IP version 6. Okay. So with this, we have completed the syllabus for your internals. Okay, I'll give you the portion. One second.